Hello, it is me, Ugo, and this is the check array problem, or more specifically, check array formation through concatenation. So, this is an easy bleed code problem. I'm not gonna lie to you, this killed me. Like my brain was struggling. Maybe it's just because it's a giant text block. I like simple problems. I like the problems that are simple. So like raining or trapping rainwater. Like like this one? Let's see if my internet works. Whatever. Um, yeah, so this one has a long description. I don't know if that's what was killing me, but my brain just did not want to work. So, yeah. It took me a second, but then I realized that basically what we're doing is we're taking advantage of the many like little details about this problem to make a simple solution. So we have distinct integers in the array, which is a one-dimensional array, and then we have distinct elements in pieces, which is an array of arrays or a list of lists. So it's a 2D array, but the all elements in the array of arrays, if all of them were flat, if the array was flattened, basically, they would all have distinct elements. That's a very key part of this whole algorithm. And our goal is simply to figure out if we can take advantage of or move around the pieces without rearranging the individual piece to create the array. So we can't reorder it. We're not allowed to reorder it. So like in this case, we have 49, 18, 16, 16, 18, 49. We would be able to rearrange this and get this, but we're not allowed to rearrange the inside of the piece. So that means that we don't actually have a solution for this one and we return false. So basically, if we are able to concatenate the pieces together without rearranging them, without rearranging their insides, then we can get the array. And if that's the case, then we return true. Otherwise, we return false. Yeah, so we're not allowed to reorder them, any of them. So this problem made my brain hurt a little bit, but this is the important part right here, and also this part right here, this part right here. So the lengths of every single piece combined in the pieces will always equal to the array's length. So what we can assume with that is because all of them are distinct, or at least my second approach was just to find, because I thought all the pieces were going to have all elements from this, but the only problem would be the order of them. That's not the case. There are test cases where you have numbers that are simply not in the array. So my original thought process was, okay, since everything is distinct and the lengths are the same, then all we have to do is just look to see if the order is the same. Now, in the actual solution, you need to do one more check beforehand, but that's not a big deal. So that's basically what I was doing. I was just, first, I would find the location of the starting point, because since it needs to be in order, we need to find the starting index of a piece. So the first element will be the start index, and we're just going to find its location in the actual array. So like, let's say right here, we have 88. We locate 88 here, and we're going to store the index that we found it at, which would be 1, in a dictionary. So the dictionary will store the piece, the piece that we're currently looking at, the index of the piece that we're currently looking at, and the index of where it's located in the original array, because that'll be our starting position to go forward from there to check if the entire piece starts from there and continues and finishes after it. So in this case, since 88 is alone, that means we only have to check if this element exists, and that's true. So then that case is true. And then we go to the next one, same thing. It's 1, we continue. In this case, it would fail because we start at 18, or we start at 16. So the first element 16, we look for the 16 for 16 here. And then we start from here and continue forward. We don't see a forward, which means it's false. So that's the approach that I was going with. I had one little issue, which was index would throw a value error if it wasn't found, and that would be a case. So rather than trying to figure out if there was an actual different solution to this in Python, I don't think there is. I think I remember searching it up, or I've always run into this problem repeatedly, so I was just like, you know what, screw it. I'm just gonna make a little function that uses a try condition, error handling. We're gonna handle the error, and we're gonna handle it like a C++ person would. We return -1, because that's the proper way. None of this value error. We're -1. So -1, that's what we return when we don't find an index, or when we don't find an element inside of the array. So with that, we're gonna create a dictionary of key value pairs where the key is the piece. So we have numbers of pieces, and it's gonna be the number of the piece, 0 indexed, obviously. And then we're gonna use the locate function that I created, which is just basically index, but with error handling. So same thing. So simple. We just look for the index that the element is located at, which is going to be the first element. So that's going to be our starting position, and we're just going to look for that. We're gonna find all the starting locations that we need to check later on. Then we're gonna check really quickly if there's a -1 inside of the locations that we found. That means that we found a failure, because there is no negative index in this algorithm. This algorithm will always be positive unless there is a failure, which will return -1. So if there's a -1 in it, then that means that this won't work, because like it said here, the lengths are the same. So if one number alone is already wrong, it's already gone, because we already have one mismatch, and that's enough to cause the error, because we don't have any x's to work with. If there's one missing or one off, it's over. So we're just going to return false here. Then we're going to go into our for loop. If that's not the case, that means that we found all of the starting positions, and now we're just going to iterate through or from those positions to see if they actually are valid. So in this case, we start with 16. This isn't valid because there's nothing after it, and we're supposed to be looking for this. However, in this case, or actually probably a better case would be this one. In this one, we start at 4, and then we go forward until 64. Since the length of this is 2, we just go to check 2 elements. Once we have 2 elements and both of them are valid, we just keep going. We don't worry about it. If these weren't in here and the order that they are, then we would have to return false immediately, because like I said, one mismatch would cause this to go down because we don't have any excess due to this condition. So the big constraint is the sum of the pieces lengths is equal to the length of the original or the flattened array, and that all of them are distinct elements. So that's basically the two things we're taking advantage of. So we start at the piece start and the array start. The piece start just gets us the piece that we're currently at. Wait, items? Sorry, I don't think that's the right function call I wanted for this. But I guess it worked. I mean, I is it items? Hold up. Dictionary, Python, functions, for loops. Keys, values. I wanted values right here. Oh well, whatever. It worked. It's fine. But basically what we're gonna do first is we're just gonna check that the lengths work. So in this case it wouldn't, right? So first we're gonna check, okay, is the length of the piece greater than the length of the array after the starting position that we're at? Because if that's the case, then I think that this would just straight up fail. I think this would cause an error. This was like my version of error handling, basically. So yeah, just checking if there remains enough in the array for there to actually be a piece located in it. If that's not the case, we'll return false because that just fails immediately. And then after that base case, we're going to just check the actual code or the actual piece now. We're just going to check if the current piece is not equal to the array starting at the starting position that we found from the locate function earlier to the starting position plus the length of the piece. So that means that we're gonna check a sublist or a subsection of the list that is in the range of the starting position up to the length or past, or no, not past. We're gonna have a range that's the size of the length of the current piece that we're on, and we're just gonna check that from the starting position. So if that little array is the same thing as the piece, that means that the piece can actually be concatenated into that position, and we don't have to actually worry about overlapping because all elements are distinct. And yeah, yeah, that's pretty much it. And we just do this for all of the pieces. If none of the pieces cause any of the failure conditions to be triggered, that means that we have a valid condition, and that's when we return true. So this solution was accepted. This looked very good. I was surprised that it got this that was well received because I've never had to do error handling for a good solution, but I'm not sure if that's like just normal sometimes. It just feels so off doing this. When I was writing this code, I was telling myself that is just wrong, but I wanted to brute force it. You know, it's just I think it's a little dumb on my part, but I like brute forcing things when it's not working, but I know it's gonna work. Like I just want to see it work, even if it's bad. I'll fix it later, basically, is the type of mentality I have right there when I'm doing that. But it looked like it worked. My original solution right here. Damn, my internet is really bad right now. It's basically the same thing. It just doesn't take advantage of splicing because I realized I could just do an array splice and avoid having to loop, so I just used the loop in this case instead. But looping is slower than splicing, so splicing was just quicker. Then if we look at Python tutor, I think I have the original, like the original idea I had in mind. Just complete failure right here. It did not work at all. I don't know what I was thinking. But yeah, this is the solution I ended up with. This is like the CTI one though, so yeah. Pretty good, pretty cool. I think oh yeah, oh, hey, look. Yeah, like, see? This one's simple. I like the simple prompt. But, yeah, I got my error handling thing from this thing because I forgot what error it spews out. I was like, how do I do this? And it was like, oh yeah, you just do try except, nice and simple. So that's what I did. Literally the same code basically. Um, yeah. Oh yeah, let's see. We look at this one. Let's see. I just used the loop. So I used the while loop instead of just using splicing. When I was looking back at it, I was like, wait, I could just use a splicing thing because all I'm doing is I'm checking the range of elements in piece start. So it's like if all of the elements there exist and are the same order as the piece that we're currently on, then that means that we have found a valid condition or whatever. So I was like, I could just use splicing, and I did, and it worked. So yeah, pretty cool. I did not like the problem, but I'm surprised that it worked so well. This is like the one time I've had like the most efficient solution almost immediately, without having to search it up. Not sure if there's like a better solution. Oh, my little plan down there. I don't think there is. I mean, this looks like it's saying it's not. I mean, oh my god, I'm so tired. I'm sorry. Uh, but yeah, that's the problem.